Hi, in this video I will review chapter 10 of Clean Code book by Robert Martin. Clean Code chapter 10 is all about writing clean classes. A clean class is same as this toolbox on the left, which is labeled, which is organized, versus the toolbox on the right, which is all over the place. There are certain boxes which have a lot of tools and you don't know which tools are in which boxes. But on the left we see boxes and that are labeled, that are unique, that's easy to understand, smaller in functionality, and distributed load. So clean classes is same as labeled toolbox on the left. We all know it's very easy to use a toolbox frequently and quickly if there are small boxes that are labeled accurately. Similarly, when we write our classes, are we thinking about this analogy in mind when we create smaller classes that have a unique responsibility, that are isolated and they're easy to understand? So let's take a look at some of the principles of writing clean classes as described in this chapter. The number one is the single responsibility principle from the object-oriented design principles. So a class is clean if it has one reason to change or it is having one responsibility. It doesn't do too many things. So when you describe a class, if you find yourself describing many things that the class does, then it's probably time to break it down. It has multiple responsibilities. The second thing that helps a class to be clean is that it depends on abstractions and not on concrete implementations, which is the second object-oriented design principle, which is about dependency inversion. So dependency inversion principle, DIP, tells us that our classes should depend on abstractions, not concrete implementations, because concrete implementations can change. Abstractions allow us for better abstracting away what we depend on, allows for better testability, better mocking, and a whole host of things. Clean classes are also open for extension but closed for modification. The third principle of object-oriented design, which is open-closed principle, supports deep extension but closed for modification with private variables, public behaviors. So very, very important to have encapsulated code that is open for extension, closed for modification. And a clean class also has greater cohesion between the private variables and methods, meaning most of these methods use most of the variables, and so the class has a lot of cohesion between methods and method functions and variables. And if you see that there are certain variables used by certain classes and there are many of certain methods, there are many such methods, and it's maybe time for separating those variables and those methods out into a separate class. So if you see less cohesion, meaning less use of those variables, then over time it can make a case for separation of those classes into more cohesive units. The final point in the book was around readability, which is the clean class is one that is self-documenting in terms of its own class names, method names, variable names, and it's easy to understand. It has a single responsibility and very quick to understand what it is doing and what is its responsibility. So those are the five suggestions in this book on how to write your classes in a pretty clean way. Now you might be thinking, what happens when you encounter a class that doesn't meet these five principles? When should you change or refactor your code? My recommendation is you should do this proactively every time you take on some new work, at least during your monthly or a sprint boundary level, or at least a quarterly level, where you reflect on some of those issues that you see around maintaining your code, where you see issues around big God classes which do a lot of things that have never been refactored, which has a lot of responsibility. So proactively keeping an eye on refactoring is what I'd recommend we do when we encounter classes that don't follow these 5 principles about single responsibility, clear data dependency on abstractions and not on details, exposing a lot of public variables and not following encapsulation, less cohesion, not readable. And the second trigger for us to refactor our code is when we add new functionality. When we add new functionality, that's the time when we should really rethink the design of our existing classes and try to refactor them. And the biggest tip is to add a lot of tests if there does not exist a lot of tests for those existing God classes, which do a lot of things, to deeply understand those classes and their functionality. And then one step at a time, refactor all of those classes into cohesive, smaller units, like the toolbox that we saw on this slide. Once we have such a labeled, cohesive, small unit encapsulated classes, it becomes easier for us to maintain code on large scale. I'd like to hear your thoughts on when you have taken an opportunity to refactor your code and how did it go? Did it go well with your colleagues who had to review a lot of your code because instead of adding one functionality, you're refactoring a bunch of code? How did you end up adding new code versus refactoring? I'd like to hear your thoughts and also your comments on some of these 5 principles mentioned in this chapter, and see if you have a better suggestion. Add them to the comments below. And I got all of this content from this book. Huge credits to this author. Highly recommend getting this book. Thank you.